In this lesson, I'm going to review several problems from our worksheet on 10.1a on counting principal and permutations. The three problems I'm going to review with you are number 5, number 15, and number 17. In number 5, I'm given 5 digits and 2 letters, and I want to find the number of possible combinations of 5 digits and 2 letters, both with and without repetition. If I can repeat the digits and letters, then I have 10 digits that I can choose from the first selection, 10 from the second, 10 from the third, 10 from the fourth, and 10 from the fifth. That's all multiplied by 26 letters from the first and 26 letters from the second. And if I do the math and the calculations, I'll end up with a total number of 67,600,000 different permutations or possibilities of these combinations. In the second example, the book asks to find what happens, or how many permutations are there going to be if I cannot repeat the digits and the letters. So the first, I have 10 digits to choose from. And now that I've selected one of those digits, I only have 9. And now that I've selected 2, I only have 8. And having selected 3, I have 7 left. And having selected 4, I have 6 other possibilities left. And that's multiplied by letters with 26 possibilities. And now that I've selected one of those possibilities, I only have 25 left. And again, if I multiply all of these through, I'm left with 19,656,000 different possibilities. Now, if you just take a look at the difference, when we don't have repetition, I'm looking at about a third, or a little less than a third, of the total number of possibilities relative to being able to repeat the digits. So this is number 5. In number 15, the book is asking us to solve the following problem. 8 factorial over 9 minus 3 factorial. Now we can put this in your calculator and figure it out. We know that this is just 8 factorial over 6 factorial. But really, you can simplify this problem pretty quickly and answer it without using your calculator. So if I were to rewrite this, 8 factorial is the same as 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 6 times 5 times 4 times 3 times 2 times 1. Well, I know that 6 times 5 times 4 times 3 times 2 times 1 is the same as 6 times 5 times 4 times 3 times 2 times 1. So these values are the same and reduced to 1, and I'm left with 56 over 1, or just 56. Now the last problem I'll do for you is number 17, and in this question, the book is asking us to find the number of permutations given that I have 5 possibilities and I want to select an order of 5 from those 5. Now you remember that the equation is going to be n factorial times n minus r factorial, where r is the group or the number of selections that we're going to make. So this ends up being 5 factorial over 5 minus 5 factorial, which is equal to 5 factorial over 0 factorial. Now, one of the things that you don't know is that 0 factorial is equal to 1. So we're just left with 5 factorial as the answer, which is 5 times 4 times 3 times 2 times 1 which is 120. Let's just double check. 5 times 4 is 20, times 3, 60, 2, 120, times 1 is 120. And there's our answer.